Hi, and welcome to our lesson recap on our first lesson in our periodic functions unit. We started our lesson by considering Ferris wheels. I hope you've watched the link above this video. If you haven't, then you should do that right now. You can come back to this later. We considered what the height of a car might look like if we tracked it against its angle from the center of the Ferris wheel. And in our initial exploration, you weren't asked to start in any particular place, just to consider what it might look like if you tracked the height of a car as it went around the Ferris wheel versus the angle that the car was at from the center of the Ferris wheel. So go ahead and make a sketch about what you think that might look like. Go ahead. I'll wait. Here are some of the different types of graphs that students drew. Some drew straight lines up and down, considering the position of the cars as it moved. Others drew these kind of semi-ovals across, and some drew functions that were more smooth curves. So students were asked to consider how they decided where to locate their points on the graph, how they could have made their assumed model more precise, whether a passenger car is ever at the same height during its rotation, and how do you know? They were asked where they chose to start their car and why, and reasonably, most students had started their car at the bottom where the Ferris wheel loaded, and because that is where the ride starts from their point of view. They're asked to consider whether the height is changing in a linear fashion, and why or why not, and what patterns they noticed in the way that the height of the passenger car was changing. How the range of the graph of the Ferris wheel height function might relate to the physical features of the wheel. In the initial exploration, students were asked to consider 4 rotations, so many listed the rotations along the horizontal axis, and the height, of course, on the vertical axis. So we talked about these models, but we didn't talk about what model might be correct, because that's for our next exploration. Next, we built a paper plate model. Each group built one model. They were given a paper plate, a piece of cardstock, and a brad to affix them in the paper plate to the cardstock in the center. So they labeled the 3 o'clock position right here. This would be 3 o'clock on a clock. Up here would be 12. Here would be 3. Here would be 6. And here would be 9. The 3 o'clock position was labeled as angle 0. We didn't get into much discussion about why we did this at this time. However, we're going to talk about that more in lesson 3. You might recall from geometry that this is the position that you start measuring an angle in, and that you measure angles counterclockwise, which is how we did our rotation, always counterclockwise. So they were asked to label a passenger car every 15 degrees using a protractor and to measure the height from the bottom of the paper plate for each of those measured degrees because they represent passenger cars. And they were asked to record them in a table and plot their data points on the next page and then sketch a smooth curve. Here's my paper plate with all of these measured passenger cars at 15-degree angles. So here's 15, here's 30, here's 45, here's 60, and 75, and 90-degree angles. This was the start, and then students were asked to measure the height, which we'll see in the next. Height then was measured using a ruler with 0 set here along the bottom edge of the page up to each of the angled degrees, and I slid the ruler in under the plate towards the brad in order to get these measurements, which I've labeled on the half circle that I've shown here and then continued on the other half of the circle. So each height was measured from the bottom of the piece of paper. This gave us a consistent height and made a good Ferris wheel model because a Ferris wheel is not actually going to be all the way down on the ground, so we have this little gap here where the wheel is not hitting the bottom. Once we had all these numbers, we put them into a table. Once those numbers were plotted, we got a graph that looks something like this. Everyone's numbers were a little bit different because the paper plate position wasn't always exactly the same height above the bottom of the paper. But that's just fine. We don't all have to have the same numbers. When we plotted those points on our graph, we got a curve that looks something like this. So I could trying to draw a smooth curve here, the overall shape of the curve. And as we can see, we are going through the same heights repeatedly, and we are not moving at a linear rate. We're curving up and then back down through and then back up. And here we are at 360 degrees. So if we went around the Ferris wheel one more time and measured, we'd repeat this pattern. In closing, we considered that since this pattern keeps repeating and a set period, that is a set number of angle rotations, then we have a periodic function. It's going to repeat over and over and over again. Much more perfectly than my quick sketch here. So we gave you a formal definition of a periodic function, which is here on the screen for you to read, and asked you to write in your own words what a periodic function might be, and then to work on the problem set for the rest of the period and homework. And that's our lesson recap for the first lesson in periodic functions.